Hi students, problem number 3. A ship in a sea sends sonar waves straight down into the seawater from the bottom of the ship. The signal reflects from the deep bottom bedrock and returns to the ship after 3.1 seconds. So the signal is sent down and again it is returning to the ship itself after how many seconds? 3.5 seconds from the deepest seabed. After the ship moves to 100 kilometer, so it is coming to a new position here. Okay, so it is traveling a distance of 100 kilometer. It sends another signal which returns back after 2 seconds. So after traveling through 100 kilometers, it is sending another sonar signal and it is retracing it after 2 seconds. Now calculate the depth of the sea in each case. And also compute the difference in the height between the two cases. So once or twice you have to read the question and understand first. So when the ship was initially at some position, say for example position A, it is sending the waves up to the seabed. So let us take the depth is D1. So after reflecting from the bottom of the sea, it is traveling another distance D1 in the upward direction. Okay. So here the distance, total distance traveled by the sound wave, that is equal to D1 plus D1, that is 2D1. And the time taken in the first case, let us take that the time taken T1, that is equal to 3.5 second. So in the first case it is 3.5 second. In the second case, after traveling 100 kilometer, how much distance in one direction it travels is D2, that is the depth at this rock, and it is retraced the same distance D2 in a time equal to 2 seconds. So here the time taken T2 is equal to 2 seconds. And here in both the cases the sonar is sending the same sound waves only, is it not? So the velocity of sound in water is taken as 1450 meters per second in both the cases. Okay. So in the first case the total distance is how much? 2D1. In the second case the total distance is what? 2D2. So I will take the case 1 first. So 2D1 distance divided by the time T1 is equal to the velocity 1450. Okay. So 2D1 divided by time T1 is how much? 3.5. So this is equal to 1450. So now we want D1. So D1 is equal to 1450 into 3.5 divided by 2. So this is 1450. So this is 725. Okay, into 3.5. So we will use the calculator to find the value. Okay. So 1450 divided by 2, that is 725. Already I have written. So this 725 should be multiplied by 3.5. So the value is coming as 2537. So this is equal to 2537.5. So we have to find the depth in each case. They have asked, no, find the depth of the sea in each case. So at position A, the depth is D1. Therefore, depth D1 is equal to 2537.5 meter. So this is the first value. Similarly, now for the second case, okay, at position, let us say this is a B. So at this position, this 2D1 must be equal to 14,500 into T2. So this is equal to 1450 into T2 is given as 2 seconds. So into 2. So 2d1 is equal to, so 2 and 2 get cancelled, therefore we get the depth here must be what? d2. Okay, so d2 must be equal to 1450 meter. So this is the depth at position B, that is d2 is equal to 1450 meter. Now calculate the depth of the sea in each case. In each case the depth we have determined. Also compute the difference in the height. Therefore delta H is equal to what? d1 minus d2. So this is equal to 2537.5 minus 1450. So this difference you have to find out. Minus 1450. So 1087. So this is equal to 1087.5 meter. So the difference in height, delta H is equal to 1087.5 meter. This is the required final answer. I hope you must have understood well. Fine.